Well, today we are going to talk about congruent figures, and we will be determining how to tell whether two figures are congruent or not, and we will be talking about what their corresponding parts are. So, congruent figures have the same size and shape, so that's the most important thing for you to take away from that here. They look alike, and it looks like they're congruent. The size and the shape of each of the sides and the angles are congruent. When the two figures are congruent, you can flip it around, you can rotate it, you can translate it, and you should be able to make it so that one will fit right on top of the other and be exactly the same. So when two figures are congruent, they are exactly the same in every way. So our definition of congruent polygons is that they have congruent corresponding parts. Now their corresponding parts are the matching sides and angles. For example, angle B would correspond to angle F in this quadrilateral. Angle A corresponds to E, D corresponds to H, and C corresponds to G. And when we label our polygons as being congruent, the order of the letters shows us what parts correspond. So it's very, very, very important how we label each of these, okay? So you can tell just by the statement that says the quadrilaterals are congruent what parts are congruent just by looking at the order of the letters. That tells you what parts correspond. All right, so let's go ahead and jump in. Let's find some congruent parts here. It says if quadrilateral HIJK is congruent to LMNO, what are the corresponding congruent corresponding parts? Well, we could try to struggle with some of these figures and figure out which parts correspond. The easier way to do that is just to look at the order of the letters. This says H corresponds to L, I corresponds to M, J corresponds to N, and K corresponds to O. So our congruent sides are going to be HI, side HI will correspond to side LM, and that's over here, that's like the bottom side here, those are corresponding. And the order matters. We would not say HI is congruent to ML, because that would imply that M corresponds to H, and it does not. M corresponds to I. So this is, you really need to be careful on these, that you're giving the right order of each letter. Another one of the sides, IJ, so the next one, IJ, will correspond to MN. The third side, JK, will correspond to NO. And the last side, KH, will correspond to OL. Likewise, each of those angles, angle H will correspond to L, I corresponds to M, J corresponds to N, and K corresponds to O. So those are all congruent sides and angles. Remember, in order for congruent polygons to be congruent, every one of their angles must be equal, and every one of their sides must also be congruent in length. So here's a chance for you to go ahead and try what we just did in the last problem. See if you can write, if we have a triangle WYS that's congruent to MKV, what are the congruent corresponding parts? Go ahead and write out the sides and the angles, and I'll give you the answer when you come back. All right, I hope you took some time to try to figure that out on your own. The sides that would be congruent, we would have side WY is congruent to side MK. We should have side YS is congruent to side KV. And we should also have side SW should be congruent to side VM. And these are all segments, okay, so we should put our segments above those because they are segments that correspond to the sides. So let's label those accurately. Then it asks us, what are the congruent angles? Angle W should be congruent to angle M. We should have angle Y should be congruent to angle K. And we should also have angle S is congruent to angle V. All right, so let's keep going here. Here we have a multiple choice question about the SR-71 Blackbird aircraft. And it says that the wings suggest congruent triangles. So if you look at this picture right here, it looks like these two triangles, which they blow up here for us, look like they're congruent. What is the measure of angle D? We want to know the measure of angle D down here. So it's a multiple choice question. So let's go ahead and take a look at what we can write. We know from triangle ABC that the measure of angle A plus 30 plus 75 has to equal 180. So we can solve for measure of angle A, then we know that must be 75 degrees. And angle A corresponds to angle D. We know that angle B and E are congruent, and it looks like C and F are corresponding and A and D are corresponding. So since angle A corresponds to angle D, we should get that angle D is 75 degrees, which would make B the correct answer. Here's another one for you to try. Suppose that triangle WYS is congruent to triangle MKV. If the measure of angle W is 62 and the measure of angle Y is 35, what's the measure of angle V? And how would you explain what that is? Well, in this problem, if we're given that these are congruent, each of those parts correspond. W corresponds to M, Y corresponds to K, and S corresponds to V. And we're given W and Y in this triangle, so we can figure out what angle S is. And angle S is congruent to angle V. So if we can figure out angle S, that's the same as angle V. So if we just take 62 plus 35, 62 and 35, that gives us a total of 97 degrees. And we know that there are 180 degrees in every triangle. So 180 minus 97. All right, so we need to borrow from our 8 here. 10 minus 7 is 3, and 17 minus 9 is 8. So this should be the measure of angle S equals 83 degrees, and that's also equal to angle V. So angle V is 83 degrees. The next problem says, with this figure, we're going to look for some congruent triangles. Are the triangles congruent? And if so, let's justify our answer. Well, one of the things that we can do is to go ahead and draw these triangles so that they're in the same position. So triangle ABC is drawn here, and then triangle EDC is drawn where we flip that around a little bit. You bring that corner E down to the bottom. And if we look at the figure, they give us some things that are congruent. What do all these little marks mean? Well, we are given that side BC is 4 units long, which is congruent to DC. We're given that AC is 6 units long, which is congruent to EC. We're also given that, we also know that side AC is congruent to EC, BC is congruent to DC because they have the same length, but we also know that AB is congruent to ED, and that's given by the figure here. That's what that little dash means. Well, what about their angles? From the figure, the drawing, we know angle A is congruent to angle E, and angle B is congruent to angle D. That's what those markings mean. Well, we've already got all 3 sides are congruent, and we've got 2 of the 3 angles. Can we prove that angle C is congruent to angle C? Well, that is true because if you look in the figure up here, angle C from the first triangle is angle BCA, and angle C in the second triangle is angle DCE, and those happen to be vertical angles. So vertical angles are always congruent, so we know that those 2 angles are congruent. Therefore, we know the triangles are congruent because all of their sides and all of their angles are congruent. So we can say that those are congruent triangles. Here's one for you to try. Is triangle ABD congruent to triangle CBD? And justify your answer. Go ahead and try this one. Pause the video and I'll help you out when you come back. Well, I hope you gave that a try. This figure, we would have triangle ADB. Okay, would look like this. See if I can get this to work for me here. This is A, this is B, and this is D up here. And that side AD is congruent to, now we have the other triangle, and I should draw this, let me erase this. I should try to draw this so that the parts are corresponding so that they look like they're in the same position. So let me try that again. So then ABD should correspond to CBD. So if I draw CBD, that should look something like this. Okay, where this is going to be angle C, this is going to be B, and this will be D up here. So kind of imagine that. I'm going to take off just one little piece right here. There we go. That looks a little better. So are these congruent? We know that side CD is congruent to side AD. Well, do we have enough information? In order to say that those triangles are congruent, we need to know that all of their sides and all of their angles are congruent. And right now we know that AD, side AD, is congruent to side CD. And what else do we know? There's one other side that we can get to be congruent, and that would be side DB right here is congruent to itself. We could say that this one is congruent to this one. So we could say DB is congruent to DB. What would be our justification for that? Well, our justification for that would be that reflexive property. Anything is congruent to itself, reflexive property. Can we get any other sides to be congruent? Well, we have no reason to assume that AB and CB are congruent, and they don't tell us any of the angles are congruent. So we cannot conclude, so there's not enough info to conclude that those are congruent triangles, okay? Here's a theorem that we'll be using. This theorem says if we have two angles in one triangle congruent to two angles in another triangle, then the third angles are also congruent. Well, that'll be helpful for helping us decide whether or not two triangles are congruent or not. So as long as we have two angles congruent, we can conclude that the third one is congruent. Let's see where we could use that. So in this problem, we're going to prove that these two triangles are congruent. We want to prove triangle LMN is congruent to triangle LON. And we're given a whole bunch of stuff that's marked in our figure. So let's go ahead and jump in. Well, we know that LM is congruent to LO, and MN is congruent to ON, and those are the marks on the figure. Those are given. Okay, we also have some angle measures that are given where they're congruent. LN is congruent to itself by the reflexive property. So now we have all three of those sides are congruent, right? So this is congruent to itself. I'll use 3 dashes for that one. So item number 3, angle M is congruent to angle O. And in our figure, angle MLN is congruent to angle OLN. That's the one in the corner here. Those two are congruent. That was given. So we have all three sides are congruent, and we have two of the angles congruent. Well, all we need is the last two angles to be proven congruent, and these triangles will be congruent. So we can say that the last angle is congruent from that theorem from the last slide. The third angles theorem tells us if we have two angles that are congruent in a triangle, then the third ones have to be congruent. So angle MNL is congruent to angle ONL from the third angles theorem. Therefore, we can say triangle LMN is congruent to triangle LON by the definition of congruent triangles. We have proven that all three sides and all three angles are congruent, so the triangles are congruent. Here's one for you to try. There's a whole bunch of given statements. Let's start with, when you write your statement, start with all of your sides that are given to be congruent, and then what you're given for your angles. So in order to prove this, remember you have to prove that all three sides and all three angles are congruent. So let's see if you can come up with that proof on your own, and we can talk about that when you get to class. See you next time.